Welcome to Advance U and MVU's educational video on fogging and misting. By the end of this session, you will be able to define fogging and misting and understand indications, identify benefits and limitations of space sprays, and plan, implement and complete a treatment. What does the term space spray actually mean? A space spray is when insecticide is released as a fine mist into the air. The droplets move through the space and contact insects that are flying or resting in the treated area at the time of application. As the droplets are so small, they remain airborne, giving fast control of insects that are present in the treated space at the time of application. The fine droplets contact the insects directly, entering the insect through inhalation, causing rapid knockdown and death. What equipment is required? A pest manager can use either a fogger or a ULV mister. A thermal fogger uses heat to turn the insecticide mixture into a vapor. As it leaves the machine and cools, it forms a dense cloud of very fine droplets that move through the treated space. A ULV mister uses high-speed air or mechanical force to break the insecticides into very fine droplets without using heat. These droplets are then carried through the air to contact insects in the treatment area. The high PSI and small droplet size forces pesticide into cracks and crevices to give a more thorough treatment. What are the limitations and risks of space sprays? Space sprays work best on insects that are exposed to the mist at the time of treatment. Once the droplets settle, especially on porous surfaces, the pesticide can soak in and may provide little ongoing control. Because the pesticide is meant to be airborne, there is also a risk of breathing it in, getting it on your skin and in your eyes, or allowing it to drift into areas that should not be treated. This poses both an environmental threat and a risk to the occupiers and operators of the machines. Before carrying out a space spray, start with an inspection and build an integrated pest management plan. Identify the pest, work out how it is getting into the building, and look for conditions that are providing food, water, shelter, or breeding sites and allowing the pest to complete its life cycle. These conditions should be corrected wherever possible, and entry points should be sealed or managed to reduce the chance of the pest returning. To calculate the building's volume in cubic meters, measure the length, width, and height in meters, and then multiply the three measurements together. Length times width times height equals cubic meters. For example, this building has been measured at 10 meters long by 8 meters wide by 2 meters high, which equals 116 meters cubed. A product must then be selected based on its formulation characteristics. Here is David Arnold to explain.
So looking at products that we have available, there's two clear alternatives when we look at the ULV and thermal fogging areas. One is a true water-based formulation, which has a lot of advantages with obviously being a safer product to use. Once we get to the point at looking at the carrier-based surfactant or oil-based formulations, they need a lot of heat to allow them to move, and they also have added risks with the heat and then staining. So one of the big advantages with a water-based formulation like Aqua K is that we can use it in those safer environments, less environmental risk. And the beauty with Aqua K, and one of the downsides to it as well, is actually trying to work out the application rate. So the amount of millage going into a square metre is quite low.
How do we prepare the product and equipment for use? Calculating how much product you need starts with reading and interpreting the product label. Let's work through an example together. Shane is treating Indian meal moths in a facility storing grains and oats. He will be using Aqua K Othrine. The product label tells Shane to apply 2.5 millilitres of product for every 1,000 cubic metres of space. Now that we know the volume of the building and the application rate, we can calculate exactly how much product Shane needs. Let's do this math together. Take the total volume of the space, 160, and divide it by 1,000 is stipulated on the label, and times this by the amount of millage required per 1,000 meters cubed, which is 2.5. That equals 0.4 mils. A pest manager needs to select the correct tool for the job. In this case, Shane is selecting a Hurricane ULV mister. A small droplet size of 50 microns can be achieved with this mister by having the setting on position 3. This will expel 281 mils per minute. It's also important to read the manufacturer's guidelines of the equipment before you use it. In this case, it states not to use more than 2.7 litres per 1,000 metres cubed. Doing so can be both hazardous and wasteful. Therefore, Shane will only need to mix 500 mils of water with his 0.4 ml of Aqua K Othrine. Preparation involves shaking the product well and measuring out the required amount on a level surface with an impervious floor and bunding. It's best to transfer the measured amount into the container of water for ease of mixing and transferring into the equipment. As always, return the lid and product back to the storage area. Always ensure you're wearing appropriate PPE as per the product's label. In this case, Shane wears PVC gloves, coveralls and a full face mask. He then pours the mixed concentrate into the application equipment tank. Vehicles must always be secured to prevent unauthorised access when a pest manager is not around. Always follow a safe work method statement which identifies the hazards associated with the treatment and the controls required to manage them safely. This includes wearing the correct PPE, e.g. a full face mask, ensuring the treatment area is clear of occupants, securing the building and controlling air movement to prevent pesticide drift into non-target areas. It is also important to consider the entire life cycle of the pest. For Indian meal moths, eggs are usually laid on or near suitable food sources. Larvae feed within the stored product and may be concealed within webbing or food material. When ready to pupate, they often move away from the food source and form pupa in cracks, crevices, and other dark, undisturbed areas. Adult moths may then be found flying within the facility or resting around the ceiling walls, lights, and windows. To further reduce the chance of pesticide exposure, the operator may turn on the hurricane mister and leave it to apply the mist to the treatment site. Note just how wet the site can become just with a small amount of volume. Once the treatment is complete, turn off the equipment and keep the building closed and secure for the re-entry period specified on the product label. Re-enter the site wearing the appropriate PPE and inspect the site for signs that the treatment has been effective, such as dead insects. Depending on the level of activity, further treat if required. Once the inspection is complete, ventilate the building thoroughly and begin the cleanup process. All exposed surfaces will be wiped down, contaminated food or stored products removed and disposed of responsibly, and the entire area vacuumed thoroughly using a HEPA-filtered vacuum. Finally, put a monitoring plan in place, leave suitable insect monitoring stations throughout the facility, and return after a few weeks to check for any signs of continued activity or reinfestation. Thank you for listening, and we hope you've enjoyed this educational session.